At the first of our types of quadrilaterals called a trapezoid. Uh, we'll, we'll look at this sheet first, which has the information about trapezoids and the properties. It is a quadrilateral because it has four sides. But a trapezoid has one pair of parallel sides. So only one set of the sides is parallel to each other, not the other side, two pairs, or the other pair of sides. The median is half the sum of the bases. The adjacent angles along a leg are supplementary. We'll look at each one of these things separately. An isosceles trapezoid is the same as above, except the two legs of it, the two sides that aren't parallel, are the same length. And this is true as well. The base angles are congruent and the diagonals are congruent. So what a trapezoid looks like is it's got two sides that are parallel and two sides that are not. So these two sides are parallel to each other. That's a trapezoid then. These two parts are called the bases. And so we use little subscripts, base 1 and base 2. It doesn't matter which one you call 1 or 2. Those are the two bases of that trapezoid. The parts of it are, if you talk about the median, what it does is it finds the midpoint of each side. So it's kind of like the mid segment of a triangle. It just joins those two things like that. And so this is the median. And there's a relationship between those and the fact that the median is equal to half of the sum of the two bases. So you add the two bases together and divide it by 2, and that's the median. Likewise, if we were to multiply both sides of this by 2, so 2 times the median is equal to the sum of the bases. So if I knew one or the other of these, I would double the median, and that's the sum of the bases. That's what we're going to use today, is that idea. So we're going to look at some examples. And there's some numerical examples, and there are some that are algebraic. So let's take a look at a couple of these examples. Oops, boy, this is really big. Make this a little smaller here. So let's say we're going to find the length of the median of this trapezoid. Oh, my technology's going wild here. Okay, so I know that the median is half of this sum. So I know that the question mark here is 1/2 of 6 plus 16.2, which is 1/2 of 22.2, which equals 11.1. And that's what the length of this median would be. All right, numerical examples are really easy. Now, what if I gave you the median and one of the bases and we want to find the other one? Well, we can still set it up the same way. The median is 1/2 of base 1 plus base 2. So 9.6 equals 1/2 of, if I call this base 1, that's the question mark, plus base 2, which is 12.8. Now I want to solve this for this question mark. So I multiply by 2, and I get 19.2 equals the question mark plus 12.8. Now we just subtract 12.8. So the question mark equals whatever that comes up. Borrow the 1. 12 minus 8 is 4. 18 minus 12 is 6. So the question mark equals 6.4. To do these algebraically really is the same thing. This median is equal to half of this plus this. So what I'm going to do is on all of these problems, I'm just going to double the median. And that has to equal the bases added together. Now it's a matter of solving this algebra problem. 8x minus 2 times 13 is 26, equals 24 plus 46, which is 70. Add 26 to both sides. We get that 8x equals 96. Divide by 8, and I get that x equals 12. Do one more example. Let's look at, say, this one right here. I'm going to double the median, 2 times 16, and that's going to equal 2x plus 1 plus the other base. So 32 equals 2x plus 12. Minus 12 from both sides, I get that 2x equals 20. So x equals 10. And you can check just to see if that makes sense that it works. If I put 10 back in here, 2 times 10 is 20 plus 1. This would be 21. 21 plus 11 is 32. Divided by 2 is 16. So it works. And those are the examples like what's on your homework for today.